Hi, I'm Steven Feuerstein, and I write practically perfect PLSQL.
Greetings and welcome to the PLSQL Channel, a series of video trainings on the Oracle PLSQL language. My name is Steven Feuerstein, and I'm a PLSQL developer just like you. This lesson is a part of my series on writing dynamic SQL in the Oracle PLSQL language, and the focus of this lesson is on executing dynamic PLSQL blocks of code. So first of all, how can dynamic PLSQL be of benefit? I bet there's a really good chance that you have run dynamic SQL statements, dynamic queries, dynamic updates, etc., but maybe never actually executed dynamic PLSQL, a block of code. So consider the code on the right. This is from a real-world experience that I had years ago in an insurance company in Chicago. So this program was basically written over a long period of time to process different line items. For an insurance policy, they'll have different clauses that essentially escape the insurance company from having to make payments, claims, or minimize the amount of payments. And every time they came up with a different line item or rule, it was expressed in a different process line procedure, process line 1, line 2, line 3. And then whenever they ran their job to process a claim, it would run each of the different line items. And this body of code over a period of years had grown to something like 20,000 lines long. That's how many different line items they had to process. And every time they had a new line item, they would add a new clause over and over and over again. Now this is a long time ago, so it was back on Oracle 8, I believe. And so there were limitations on the size of the code, and they were concerned about it actually getting too big to compile. And in any case, it was taking a really long time to compile. So the maintenance on this program was a total nightmare. And they said to me, Steven, can you help me? Is there a way that we can address the problem in this code? And I've got to say it was a really nice moment, because for DBAs and consultants who do database administration, it's not that hard to be a hero. Oh, you need to make your database run faster? Here, we'll put on an index, and suddenly everything's better. In the context of PLSQL, if you can improve performance by 10%, you're amazing. If you can reduce your code volume by 5%, you're amazing. But in this case, I was able to do so much more. Now, first of all, before I show you the solution, what I did, let's do a little bit of code analysis. First of all, notice that we have these if clauses, if after if after if. This, of course, is a really bad idea all by itself. If the line item is 1, it's not going to be 2 or 3 or 4 or anything else. So here's a situation where I had mutually exclusive clauses, but they were expressed in a series of if statements. At a minimum, this should be else ifs or a case statement. But I could do way better than that. And I could do way better because I noticed a pattern. We had the process line prefix and then the line number over and over and over again. And whenever you see a pattern, a repetition in your code, you should automatically think about dynamic SQL or reusable code. Now, this is one reusable program, process line item, that passes in the line number, so that doesn't help us. But maybe dynamic SQL. And that's in fact how things ended up, and it was a really wonderful moment. I took their 22,000 lines of code and brought it down to something like 10. So I took the pattern and expressed it in my code in a dynamic PLSQL block. So process line item became nothing more than execute immediate, and then I constructed my PLSQL block in which I call process line, concatenate the line number, and wow, that's it. All that code goes away, and when a new line item is added, all they have to do is create the process line 26,074 program, and this driver will not have to change at all. So I thought this was a great example to lead in on this lesson of how dynamic PLSQL can have an enormous impact on either the quality of code, the maintainability of code, and even the performance. In this case, the performance when I execute line 1 or 2 might not be better than this, though there's not a lot of overhead in simply parsing a small block like this. Whoops, let's turn that off. But when I get to line 22,000, almost certainly the cost of going through all these different rows, all these different line items and if clauses, is going to be slower than simply executing the block of code. And before I continue, let's just turn off my Skype so we don't get interrupted anymore. My apologies for that. Okay, so there's a great example of how dynamic PL/SQL can have an enormous impact on your code. Let's explore further. So dynamic SQL possibilities. First of all, what can you do with dynamic PL/SQL? Well, you can do just about anything. Think about it. With dynamic SQL, you're constructing an SQL statement on the fly, so you're restricted to what SQL statements there are. With dynamic PL/SQL, you construct and execute a block of code on the fly, so you can construct entire applications dynamically. So what have I done? Well, I've reduced code volume, improved maintainability. That's the example I just showed you. I've written some very generic utilities, for example, a generic string parsing engine that will parse any string and deposit it into your own collection. I'm going to demonstrate what I'm talking about there later in this lesson. I've implemented support for indirect referencing. This is a feature back from Oracle Forms and SQL Forms that is really powerful. If I don't know the name of my variable until runtime, for example, the name of my package might be dynamic, therefore the name of my variable or function inside the package is also dynamic, then I want to be able to construct the name at runtime and retrieve the value and change it. That's not supported directly in PL/SQL, but you can do it with dynamic PL/SQL, and I'll give you a flavor of that code in just a moment. More generally, you can soft code business rules in your application. So take the code, the rules, put them in a table, construct and execute them on the fly. Not very difficult to do, of course, depending on the complexity of your rules and how many values are going in and coming out and so on. And we'll talk about some of the details of that. But you can pretty much do whatever you want with dynamic PL/SQL. Now, in this lesson, what I'm going to do is go over the basic rules, how to go about writing dynamic PL/SQL code, some of the issues you might run into, and I'll go through the steps that I think you should follow to construct your dynamic PL/SQL implementations. Before I do that, I had mentioned the support for indirect referencing. If you ever have a situation like this, so you need to actually get the value of a variable or change the value of a variable, and the variable name is not set until runtime, check out the DYN5 package. So the dyn_var package says assign this expression to that variable passed as an in-out. Get the value of a named variable. Copy a value to a named variable. So I'm not going to go through all the details of this. I'll be showing you examples of all this kind of code later on as I get into the details of it. But you might try it out and see what you think. And again, if you ever run into any requirements that involve constructing the name of your variable at runtime, that's the package to use. Okay, so let's get into the details. What is involved in writing dynamic PL/SQL? Well, first of all, generally speaking, what it comes down to is you're dynamically constructing, compiling, and running an anonymous block with execute immediate. Now, you could also do it with DBMS SQL, no question about it, but I don't see any reason to do that. At this point, you should always use execute immediate for dynamic PL/SQL. Much easier to write and faster. So you're constructing and running anonymous blocks. And you'll use the using clause just as you would with dynamic DML, updates, inserts, deletes, to pass values in and also to get values out of your PL/SQL block. I had talked in the Method 2 Dynamic SQL lesson about bind variables and how they have modes in, out, and in, out. And generally speaking with DML, you're only using ins. But with PL/SQL, it's very common that you will use outs and in-outs. And you don't use the into clause with dynamic PL/SQL. That's only for dynamic SQL method 3 or execution of queries, fetching data into. So you'll only use the using clause at most, and not the into clause. Some rules for writing and running dynamic PL/SQL. The block that you execute has to be a valid anonymous block. It has to start with begin or declare, and it has to end with end semicolon. And again, that block must end with a semicolon. Otherwise, it is parsed as an SQL statement. Many people who have been around Oracle for a long time think that SQL statements end with semicolons because that was the SQL Plus default character to specify execution of the buffer. But in dynamic PL/SQL, Oracle is more strict. A semicolon only terminates PL/SQL blocks and not SQL statements. And you can only reference directly program elements that are accessible at the schema level. In other words, local variables cannot be directly accessed inside a dynamic PL/SQL block. All right, let's take a look at some examples. First of all, my dynamic SQL driver. Here's a little exec dynamic PLSQL just to use for my demonstrations. I'm going to pass in a block. I'm going to ask whether or not I want to trace, whether or not I want to re-raise the error. The block is passed in, and then I construct a valid PLSQL block from it. So in case somebody forgot to put it inside begin ends, I'm going to make sure that it starts with begin, ends with a semicolon, and then has an end statement. I can display the block if I choose to, and then simply execute it. And here I'm assuming that there are no bind variables. We'll come back to the using clause and bind variables in a moment. So this is a very simple case. Construct a block of code, execute it. And if something goes wrong, I'll display the error message and the code. So that's a very basic example and a little utility for running dynamic PLSQL. Let's take a look at the no local script. So what I'm going to do is run through a variety of efforts to change a value of a local variable or a global variable. So first of all, here's my local variable. I'm going to construct a block of code that does an assignment of ABC to my local variable. Now, I don't have to put it inside begin ends because my driver will do it for me, my little utility, but let's do it to make sure you see that it has to be a valid begin end block. So there's my assignment, ABC to local variable. Local variable is defined right there. I do want to turn on tracing. I don't want to re-raise the exception. If it occurs, it'll just display a message. Let's try this. Looks reasonable. There's the variable. There's the variable. Run my code. And here's what I see. Dynamic PLSQL error. Identifier local var must be declared. So the thing to recognize here is that even though I'm constructing this block of code and it's seeming to execute it inside the scope of this block is actually executed at the schema level outside of the scope of this local block, of this anonymous block. Local variable cannot be directly referenced from within my PLSQL block. It's not known. That's what this message is saying. In addition, notice that my block looks kind of strange. That's the trace of the block. Begin, begin, end, end. Well, it does look kind of strange, but it doesn't hurt anything. In other words, remember my little utility always puts a begin end around whatever block is sent in just to make sure that the begin end is always there. If not, you might run into problems. So you'll see the double begins, double ends. It doesn't matter. And of course, usually in your code, that won't happen. But in fact, let's see what happens if I don't use begin end. Let's do an execute immediate. Let's grab this right here. Come back here and try to execute immediate my assignment without begin end. I run this and I get invalid SQL statement. Since my piece of code did not start with declare or begin, it's not even trying to recognize it as dynamic PLSQL. And it says, well, you've got an invalid SQL statement. That's just garbage. So you always need to have begin end or declare begin end if you're declaring variables inside your block of code. So I couldn't change the value of my local variable. What kind of values can I change? Let's try this again. And what I'm going to do now is to create a package called global variables. And I'll declare a string at the package level, a variable called string, assign it the value of same old thing. A package or any stored program unit can be called from or is accessible from the SQL layer at the schema level. So this time what I'm going to do is see, let's change this to dbms output just to keep things simple. So what I'm going to do now is check the value of my global variables string before. Then I'm going to execute my dynamic PLSQL block assigning the value of amazing to my string and then display it after. Run my code. Let's get rid of all this other stuff. Run my code. And here's what I see. Before, same old thing. Run this piece of code that assigns a value to this variable. And then afterwards, the value is changed. So because the package is available for execution and reference from within anywhere in my schema, and I'm running this block of code at the schema level, I can reference my global variables .string. I can also call functions, procedures, etc. But they have to be recognized at the schema level. They have to be something you can call inside or through dynamic SQL. Moving on. Dynamic PLSQL and bind variables. So just as with dynamic SQL, you can use the using clause to replace placeholders with variable values. The big difference from dynamic SQL include two things. First of all, with dynamic PLSQL, you'll find yourself often utilizing out and in-out modes for your bind variables, because if your procedure that you're calling dynamically has an out argument, you need to get that out. And also you might be grabbing or assigning a value to a variable and simply retrieving the value of that variable. Also, with dynamic PLSQL, if you reference the same bind variable name more than once inside as a placeholder, then you only specify it once in the using clause. So if you have multiple placeholders with the same name with dynamic PLSQL, you do not supply a value multiple times, which is exactly the opposite of dynamic SQL. Let's take a look at all of this. First, let's start with the dupe bind. Now, with dynamic SQL, for example, method 2 doing a dynamic update, or even method 3, for every placeholder that I have in my list, I have to have a value. So 1, 2, 3, 4. I have to have 4 elements in my using clause. And for DML, they're always going to be in, so I don't actually have to say in, but I can if I want to. So let's try this out. I'm going to compile this program and run it. And no problems, no errors. Now, what you might be tempted to do is say, well, look, I've already supplied a value for :val. I don't want to have to supply it again, so let's leave it off. Notice Oracle lets me compile the code because it hasn't looked inside the string at compile time. It's just a string. But if I try to run it, I get an error. Not all variables are bound. So you have to have a one-to-one match between your variables, between your placeholders, and your bind variables. Now let's take a look at dynamic PLSQL. With my dynamic PLSQL, what I've done is take that same update statement and I've put it inside a begin-end block. So begin, update, end. Notice I have the same placeholder, val, low date, high date, val. But in the case of dynamic PLSQL, I only supply 3 bind variables, because once I assign a value to that placeholder by name, Oracle will automatically use the same value in every location. So you don't supply it more than once. So if I run this code, no errors. But if I try to add another bind variable, bind variable does not exist. It's trying to assign that bind variable to a placeholder, but all the placeholders have already gotten their assignments. So it works differently between SQL and dynamic PLSQL, mostly because of the fact that you can be retrieving values out to that same placeholder. It can be used in multiple ways in your code, and it has to be treated differently with dynamic PLSQL. So that's the key thing to remember, and of course Oracle will let you know if you have the wrong number of bind variables. Now let's take a look at using out and in-out. So here's a program called dyn5. I pass in the name of the column, I pass in the value that I want to set that column to, and I retrieve the total. So notice I've got a couple of different execute immediates here. Change the employees table, setting everybody's salary or commission or whatever to that value. And then I want to get the total for that column and retrieve it, send it back out. And then I'm going to call this program dynamically. So begin dyn5, pass in the column name, pass in the salary, and the total salary. So 3 placeholders, 1 placeholder for each one of my parameters. And in the using clause, the mode of my values in my using clause have to match the modes of my parameters. So to be real explicit about this, in, and out. Now if I forget my placeholders, let's save that. If I forget my modes, this is probably the first thing I would do, because I don't often do out modes. So I would just write it like that, run my code, and it tells me an in bind variable is bound to an out position. It's an out position because it's being used to retrieve the value of an out parameter. Okay, so I really do need to put that mode in, the out mode. And then when I run my code, there's my value. Notice it's a multiple of 10,000, 107 times 10,000 for 107 employees. So it did the job, it did the update, it did select my sum, and I was able to get that value back out of my code. So there's an example of using an out mode on a bind variable. And if we go back to that dynamic variable package I showed you at the very beginning, here's another example of using a different mode, and that is an out. In this case, what I'm going to do is assign this expression to the named variable. And the variable is being passed in. So I call the program to assign this expression to this variable. I construct my body of code, but notice here I have a begin colon variable. So there's my placeholder. Notice I did not declare it. I don't declare my placeholder to be of integer or number or whatever. I don't have to do that because Oracle automatically determines the type of this variable in the binding clause. And then I simply specify the variable that I want to retrieve the value that's being assigned to it. And Oracle takes care of all the rest of it for me. But if I set it as an in mode variable, that will not work because it's passing the value out. Okay, let's finish up the section on dynamic PLSQL by talking about how to go about building dynamic PLSQL code. This is certainly going to be one of the more complex and highly abstract things that you will be doing as a PLSQL developer, and I found that it's very important to follow these 3 steps. First step, build a static version of the logic you want to execute dynamically. Test it thoroughly. What I'm saying here is that when you're executing dynamic PLSQL, you've got a lot of different variables in play. You need to make sure that the code that you're executing dynamically is correct. You need to make sure that it's constructed as a dynamic string with concatenations and whatever else you're going to do correctly. You need to make sure that you're binding everything correctly. There are a lot of different aspects. And what you want to do is tackle one issue or one level of complexity at a time. So don't be debugging the logic of your algorithm while you're executing it dynamically. Instead, make sure your algorithm is right by writing a static version of it first. Then when you make it dynamic, you don't have to worry about the algorithm. You only have to worry about how you're constructing it dynamically. So you build the static version. Then you identify the portions of the static code that will need to be made dynamic. What parts of my program have to be changed with either concatenation or binding so that it can be run dynamically. And then finally convert the block using concatenation or binding, and then you can, of course, execute the block. So let's take a look at these steps with a utility that I wrote to implement a file path in PLSQL. Let's take a look at the file path program. So Oracle offers the util-file package, to read and write files. So for example, there's a program called fopen that will open a file. Well, one thing that Oracle doesn't support, has not yet implemented, is the support for a concept of a path. In other words, look in this directory, and if it's not there, look in this directory, then the other directory, and so on, a sequence of paths. So I decided that I would implement that for you. That's what the file path package does, or actually it's called file.io in the file path file. And essentially what you do is call the setPath program, pass in your delimited string and specify the delimiter. And I'll use all those different locations in that delimited list to open a file. And the basic idea is that I parse your string. I parse your delimited string, which is what all this code is doing. And I put all the different directories that you specified into my list of directories. And then when you ask to open a file, I basically try to open the file in a loop. While I still have a directory, try to open the file. If something goes wrong, go to the next directory and try again. If it succeeded, exit. So it's a very simple algorithm. And it seems to work pretty well. But here's my problem. I found myself writing yet again another string parsing algorithm. Turns out that there's no built-in program in the PLSQL language that will parse a delimited string for you, any kind of delimited string. So I have to write it myself, and I've in fact written it multiple times. And after I wrote it this time, I thought to myself, I don't want to write this anymore. I want to write a single generic parsing algorithm. Now, you don't really need dynamic PLSQL to write a parsing algorithm. In fact, you might want to check out the parse package parse.pkg, if you ever need to do any kind of generalized delimited string parsing, this package should do it for you. So you pass in different kinds of string lists. We even support multiple levels of nesting of elements for parsing. Anyway, take a look. I think it'll handle pretty much anything you need to do. But one of the problems about writing a generic program like this, my generic parse package, without using dynamic PLSQL, is that you have to use my collections to return the values. Well, what if you have your own collection and you want to use that collection? So what I decided to do with the file path package was implement a version of the generic string parsing that would be so generic that you could even tell me the type and the name of the collection that should be retrieved, that should be populated with the list of elements, and I would populate your collection. And because I'm populating your collection of your own type, it has to be dynamic PLSQL. Otherwise, I'd have to hard code the collection type. So that's what I decided to do. Take this, turn it into a very dynamic and generic implementation of string parsing. And the first step was to construct the algorithm to do the parsing. It's not necessarily all that complicated, but you sure don't want to have to deal with all this kind of stuff. Get the next string, am I at the end of the string, and so on, while you're figuring out how to execute it dynamically. So I wrote my static program in the file path package right here. I made sure that it worked. I tested out my utility. And then I went back to this code and I asked myself, well, now I want to make it really generalized and really dynamic. What do I have to change to do that? And I looked for the parts of the code that have to be dynamic and the variables that I would have to bind in. So for example, I don't want to hard code the type of the element in the collection because they're supplying the collection. I don't want to hard code the name of my collection because they're supplying the collection that I'm going to modify and add to. My string and my delimiter are both bind variables, and notice multiple locations of the string variable. And then I need to add the element to my list. And again, that's going to be dynamic as well. Okay. So I go through my code, my static code. I say these are all the parts that have to be dynamic. And then I transform my block. And essentially any piece of dynamic code has to be changed into a concatenation. Any reference to a variable needs to be changed into a placeholder. And that's what you see here. So I'm concatenating in my data type, the name of my column, the way I extend or add elements to my list, and all of my variables are placeholders. And again, repetitions of the placeholder. Let's take a look at the string to list package in which I do this implementation. So again, here's my parse program. You pass in the string and the delimiter and the name of the package and the name of the collection that owns the package. So this is only going to be useful for package level collection variables. And there are a number of different overloadings. I've got two different versions of parse that support different kinds of interfaces. We're definitely not going to get into all the details. You feel free to try this out on your own time and go exploring. But let's take a look at the basics. In my parse program, I set up a number of different elements that I'm going to be using dynamically. Basically, depending on the type of collection I've got, I may need to extend, or for an index by or associative array collection, I can just go to the next element in the list. And then here's the main thing. Here's my dynamic block. So instead of a static block of code, I've converted it into a dynamic PLSQL block that declares some local variables, including an item of the specified data type for that collection. I get rid of everything in the collection for starters, so there's my collection name .delete, and my collection name is package.collection. And then I have placeholders, :string, delimiter, :string, etc. And then my code to extend or make room and add the next element in my list. And then I'm done. So it's a very much step-by-step methodical process to make these transformations. Otherwise, you're likely to get totally lost and have a hard time getting your code to compile and to execute. And then, of course, the final step is execute the dynamic PLSQL block. That's pretty easy. You call execute immediate. You pass it the correct number of variables or expressions in the using clause. In this case, they're both in. And the main trick to remember here is that I just specify those values once. So even though I reference a string more than once, I am not going to provide a value for it multiple times. Oracle will give me an error. So I just say, all right, pass in the string, pass in the delimiter, and I'm done. And remember, the effect of executing this block is the same as if it were static. So, for example, it doesn't perform a commit unless you tell it to, or it's performed implicitly. For example, if you execute a dynamic PLSQL block, that in turn executes a dynamic DDL statement that will perform a commit. But otherwise, it's pretty much doing exactly what it would do if it was running statically. It raises the same exceptions that you would have if it was static. But what you might have is exceptions that occur at runtime instead of compile time. Since you're compiling the code on the fly, of course, Oracle can't verify the validity of your structure of your code. It can't parse it until runtime. Some conclusions. First of all, dynamic PLSQL gives you an enormous amount, really the ultimate amount of flexibility. You can literally develop your code on the fly. I've built applications where I have dynamically generated new packages, that's dynamic DDL, and then reference the elements in those packages completely dynamically because, of course, the package didn't exist when I compiled my code, doing indirect referencing to get the values of variables, all sorts of crazy, fun, exciting, and sometimes really mind-bending kind of steps. But the fact is, you can do it. It's definitely a complicated way to write and maintain your code. Only use this technique if it's needed. And it's going to be a relatively rare requirement. Most developers do not need dynamic PLSQL. Dynamic SQL handles almost all the requirements. But if you ever find yourself writing the same code over and over again, look for a way to abstract out and generalize those repetitions, and dynamic PLSQL can be a great solution for you. But the main thing is, take things step by step to avoid confusion. This is a very complicated way to write code, and most importantly, debug your algorithm before you make it dynamic. Otherwise, you'll be staring at dynamically constructed blocks of code, usually pretty badly formatted, trying to figure out what the heck is going on. So save yourself a lot of agony. Do your debugging, test and build your algorithm statically first.